this video, we're going to continue topic 8.9. We were talking about volumes of revolution by the disk method. We're going to start with example 1 here, which says using the disk method. We're supposed to find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals the square root of sine x and the x-axis, about the x-axis. And we're supposed to be on the interval between 0 and pi. Using the graph of f of x, shade the region being rotated and draw a representative rectangle. So I'm going to go back through what we just read there, and I'm going to try to analyze it a little bit. So we're supposed to find the volume. So that's what we're supposed to be doing. You're doing a disk because it says the words revolving or revolution somewhere in there. So you know that has to do with spinning that disk around. We're revolved by region bounded by the graphs of the square root of sine x. So here's our first, use different color. Here's our first graph here. And the x-axis. So I'm also using this as a boundary, which means that the cross section, or the top minus bottom that we are revolving, is that yellow area right there. It's also going to give you some information about what you're revolving around. So it says about the x-axis, meaning I'm revolving around the x-axis. And that's important because that's going to change periodically. It won't always be the x-axis. It says to shade the region, which we did. You don't have to do that. And then to draw a representative rectangle. You can either just draw a vertical line, or if you really want to draw a rectangle, and that just kind of helps you visualize that that's going to be the rectangle that turns into the disk that's being revolved around. All right, so in order to do this, remember what we're supposed to do is we are supposed to take the radius, which is basically the function, which is top minus bottom, and then we're going to square it and multiply it by pi out in front. So whenever we have volume of revolution, we always start with pi. They happen to be really nice and give me the bound, so I know I'm going from 0 to pi. I'm going to take my functions. So I know that I am taking my top function. So this is the top, and the x-axis is actually the bottom. If it helps you to write it here, that's fine. Top, bottom. So I'm going to do my top function, which is the square root of sine x. I'm going to subtract my bottom function. My bottom function is y equals 0. And then we're going to square that and put a dx at the end. We are going to go ahead and practice our integration right now. So I am looking at what I have left here. I know minus 0 is going to go away. And then the square root of sine x squared would just be sine of x. So that's not too bad. And we're going to go ahead and integrate that. When I integrate sine, I know I get negative cosine of x from 0 to pi. I know that then the pi came from that pi that was out in front. And now I'm going to go ahead and substitute these in. So I've got negative pi cosine of pi minus negative pi cosine of 0. That double negative is going to become positive. I'm going to get out my good old unit circle. I know that I've got out 0, up 1, out negative 1, up 0. This is 0 radians, and this is pi radians. Cosine of pi, cosine is the x value, so that's negative. That looks terrible. Let me fix that. So we've got negative 1 plus pi. Cosine of 0, again, it's the x value, is 1. So let's see, negative pi times 1 would just be pi. Pi times 1 would be pi. 1 pi plus 1 pi would be 2 pi. And to sort of visualize, I should have probably done this at the beginning, what you actually just did there. And what this actually looks like. Let's look at it really quick in GeoGebra. So that's kind of I have the function already in there. So that's kind of what the shaded kind of function looks like. It was only let me to go out to 3.1. But then if I took and I spinned this solid around, you can see that it's starting to spin and create a shape. Okay. Much more interesting. And then we've got to envision it as a solid base there. So you can kind of see it would actually have a solid. You wouldn't be able to see inside of it, but you can see that it kind of makes, I don't know, kind of almost a vase shape, but it's not flat on the bottom.